Hello future doctors, welcome to another wonderful session of chemistry made simple for NEET, and this is Dr. Radha Subramaniam, and today we are going to learn class 11 chemistry lesson 12, that is from organic chemistry, basic principles and techniques. This is a very important chapter with regards to NEET point of view. Many questions do come from this topic. So, better we will have a quick revision of this particular topic. So, I have tried to include all the important concepts of this lesson here. So, I will be doing it in different parts. So, this is the first part, and first we will start with the introduction. So, organic chemical compounds they appear in materials like clothing, fuels, polymers, dyes and medicines. So, who found out actually organic compounds first? Who made it first? Waller. He was the one who first synthesized an organic compound urea, that is from an inorganic compound ammonium cyanate. So, what is the formula for ammonium cyanate? NH4CnO. When he heated it, he got urea, that is NH2CONH2. You remember the formula. So, urea was the first organic compound ever to be synthesized from an inorganic compound by Waller. Okay, now what are the classification of organic compounds? So, organic compounds can be classified into, this classification is really important. So, all of you do revise this and remember this classification very well. So, acyclic, or it is also known as open chain compounds, then cyclic or closed chain or ring compounds. Then again cyclic compounds are classified into homocyclic or carbocyclic compounds and heterocyclic compounds. This homocyclic or carbocyclic compounds can be again divided into alicyclic compounds and aromatic compounds. Further, aromatic compounds is divided into benzenoid compounds and non-benzenoid compounds. So, I have also given this lesson as a nutshell in the form of a mind map, which I have already uploaded today. So, those who haven't watched it can go and watch the mind map for a quick revision. Now, how do you represent the organic molecules in three-dimensional form? So, 3D structure for organic compounds is represented on paper by certain conventions, like for solid this is the simple and dashed wedge formula. So, just look at the symbols. And the 3D image of a molecule form a two-dimensional picture that you can imagine in your mind. So, we use, this is called a solid wedge. So, it is used to indicate a bond projecting out of the plane of the paper towards the observer. See, if you are in front of something and if you are looking at that bond projecting, it is coming out of there towards you. Understand? And then the dashed wedge, this is called, because it is made of dashes, it is called dashed wedge. It is used to show the bond projecting out of the plane of the paper and away from the observer. So, solid wedges pointing towards the observer and dash wedge will be pointing away from the observer. You remember the difference well, because you will be coming across the symbols in various places. Now, heterocyclic aromatic compounds. So, it includes furan, thiophene and pyridine. See the structures over here. For your, this is oxygen, sulfur and nitrogen. So, that is pyridine here. You can see alternate single and double bonds over here. The nomenclature of organic compounds. So, to clearly identify the compound, systematic method, you have to name it because it should be internationally accepted. So, it's a common system of naming is adopted. So, it is also known as IUPAC, International Union of Pure and Applied Chemistry System of Nomenclature. So, how do they name it? They are the names are correlated with the structure, so that the reader or listener can deduce the structure from the name itself. By looking at the name itself, they can find out the structure. So, IUPAC nomenclature of alkanes. So, for straight chain hydrocarbons, so for the names of such compounds, they are based on their chain structure, that is they end with suffix ANE and carry a prefix showing the number of carbon atoms present in the chain, except from CH4 to C4H10, where prefixes are derived from trivial names. So, some compounds names are given here. Methane, see all of it ends with ANE. CH4 is the formula, and ethane, propane, butane, pentane, hexane. Hex means 6, C6, 5, pent, heptane 7, octane 8, nonane 9, decane 10, like that it goes. Isocane, that is 20, and tricontane, that is 30. Just remember this formula. At least you remember the first 10 up to decane at least. Okay. Now, IUPAC system of nomenclature. So, what is it? Many students are confused regarding how do you derive this. So, hydrocarbons are compounds which contains hydrogen and carbon atoms. So, that is why they are called as hydrocarbons. See, this is the functional group. See, OH is attached, Br is a functional group, and this is a branch CH3. See, this way it can branch, and this also is another branch. Okay, and this marked, the one marked in yellow is called the parent chain. Blue one is the branch, and pink is functional group. Then how do you do the structural representation of organic compounds? So there are three types: complete, condensed, and bond line structural formulas. So the organic compound structures are represented in several ways. First, it is Lewis structure, dot structure, dash structure, condensed structure, and bond line structural formulas. These are the important type of structures. So what about the Lewis structure? It is simplified by showing the two electron covalent bond by using just a dash. Okay, then next is we have the other compounds also coming up, but before that we can see the traditional names as trivial or common names, which is given as a table over here. CH4 common name is methane. So the compound CH3, CH2, CH2, CH3, that is called normal butane. CH3 twice CH3, because according to the difference in the structure, then the common name also vary. We will learn that all in another session. So today we are just quickly revising the common names. Isobutane, this is neopentane. Just see N-propyl alcohol, formaldehyde is HCHO, acetone, CH3 twice CO, chloroform CHCl3, acetic acid CH3COOH, C6H6 is benzene, C6H5O CH3 is anisole, C6H5NH2 is aniline, C6H5CO CH3 is acetophenone, CH3O C2 CH2 CH3 is ethyl, methyl, ether. So remember the common names, all that you have to keep it in your mind. Now coming to open chain or acyclic compounds, because they consist of straight chain or branch chain like this is called isobutane. This is called CH3, that is C2H6, 2 carbon atoms and 6 hydrogen atoms. Okay, this is isobutane. Okay, CH3, CH, CH3, here also one CH3. Acetaldehyde, CH3, CH3, CHO, aldehyde group is CHO, you write it like this. Okay, then acetic acid is CH3COOH, because between carbon and oxygen always it is a double bond. Okay, OH is attached with single bond, remember that. Okay, and acetic acid you can also write it as CH3COOH. That way also you can represent the structure. Now, bromobutane you can represent it like in three forms. First one is straight chain, CH3, CHBr, CH2, CH3. Then you can write it like this, see, CH3, CH, CH2, CH3, Br. Then this is another way. So all these structures I will be explaining it in another class for you. Now aromatic compounds, these are special type of compounds which includes benzene and other ring compounds, benzenoid aromatic compounds. See, this is C6H6, always hexagonal structure, you have to put alternate, this is single bond and this is double bond. Okay, and this is aniline. If you attach NH2 over here, that is called aniline. Naphthalene, see, two structures are attached together, that is called naphthalene. The non-benzenoid compound, tropolone. See, this way the structure, you have to remember the structure always, don't forget, it's very important. Now cyclic compounds, the bond line formulas are given like this. See here, cyclopropane, CH2, 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 like this is a triangle. Okay, now here all are CH2, now 5 sides are there, so it is given like this. Then here cyclopentane, all CH, just this alone is CHCl, for that you put Cl here, or just a simple ring like this, simple structure like this. This is called chlorocyclohexane. Now alicyclic or closed ring compounds. Alicyclic is also known as aliphatic cyclic, they contain carbon atoms joined in the form of ring. Okay, sometimes atoms other than carbon atoms are also present in the ring, then they are called heterocyclic. Okay, only if they contain carbon atoms they are called homocyclic. If other atoms are also there, it's all known as heterocyclic. Cyclopropane, cyclohexane, then here cyclohexene, this is an alkene, so it's a double bond here, tetrahydrofuran, remember the structures well. Okay, now with that we are coming to the end of this session, and it's really easy if you can revise it every part. So always, as I say, do like, share and subscribe to our channel Chemistry Made Simple for NEET, and I am very happy to see your overwhelming response to the channel. Many of you are visiting the channel and subscribing to it, and I thank you all for supporting me, which is mainly the strength of our channel. Thanks for watching.